In today's lesson, we'll be looking at angle relationships in quadrilaterals. Before we begin, let's take a look at some common quadrilaterals, which happen to be four-sided figures. Over here, we have a square. This is a rectangle. This would be a rhombus. This would be a trapezoid. This would be a kite. And that would be a parallelogram. As you can see here, we have a quadrilateral, more specifically a trapezoid, whose interior angles are labeled in green and whose exterior angles are labeled in red. Is there a relationship among the interior angles? Let's take a look. 115, 115, 65, and 65. If I add up these interior angles, the sum happens to be 360 degrees. Let's take a look at the exterior angles of 65, 65, 115, and 115. If I add these exterior angles up, you'll also see that they have a sum of 360 degrees. We'll have to look at another quadrilateral to see if this pattern is true. Over here, we have another quadrilateral, more specifically a parallelogram. Let's see if that relationship we found earlier exists with the interior angles. So I'm going to add 120, 120, 60, and 60. And the sum of these interior angles also happens to be 360 degrees. I'm going to do the exact same thing to the exterior angles. So I'm going to add 120 to 120, as well as to 60 and 60 again. And the sum of these exterior angles also happens to be 360 degrees. We can now safely conclude that the interior angles of a quadrilateral add up to 360 degrees. In other words, A plus B plus C plus D will give you 360 degrees. That is the relationship as an equation. Furthermore, we can also conclude that the exterior angles of a quadrilateral also add up to 360 degrees. In other words, W plus X plus Y plus Z gives you 360. And that is this relationship expressed as an equation. In our first example, we need to determine this unknown angle. Based on our investigation, we already know that the sum of the interior angles within a quadrilateral must add up to 360 degrees. I can express this as an equation. 125 plus 63 plus 75 plus x is going to be equal to 360. At this point, we can identify like terms. 125, 63, 75, and 360 are all like terms. I'm going to be moving 75, 63, and 125 to the other side of the equation. When I do so, these numbers, which were once positive, all become negative. If we take 360 and subtract 125 and subtract 63 and subtract 75, you should get 97. Therefore, the unknown interior angle is 97 degrees. In our second example, we have a quadrilateral, more specifically a trapezoid, whose exterior angles are given as expressions. We already know that the exterior angles of any quadrilateral should add up to 360 degrees. I can express this as an equation. 2x plus 2x plus 3x plus 30 plus 3x plus 30 should give you 360. At this point, you want to identify like terms. 2x, 2x, 3x, 3x are all like terms, while 30, 30, and 360 are like terms as well. I'm going to be moving this 30 to the other side of the equation, as well as that 30. When I bring them to the other side of the equation, they are no longer positive and they become negative. I can simplify the left side of the equation. 2x plus 2x plus 3x plus 3x is equal to 10x. Meanwhile, on the right side of the equation, 360 subtract 30 gives you 300. I can now solve the equation by dividing both sides by 10. These 10s cancel out, and x is equal to 30.